Okay, I think everybody should be here now. I welcome everybody to this webinar about graphs in action, interaction techniques. My name is Benjamin Niedermann. I'm a software developer at Yworks, and I'm happy to welcome you to the fifth episode of the series about the art of graph visualization. In this series of webinars, I explain you how to create not only beautiful, but also meaningful and useful graph visualizations. And with meaningful and useful graph visualizations, I mean graph visualizations that you can use to visualize and visualize your connected data and gain new information from these visualizations for your data. In the last 4 episodes, I explained the most important aspects, including the problem setting, analysis, and layout and styling. And today I would like to talk about interaction. So in the very first episode, I gave a very broad overview about different aspects that you could consider in graph visualizations. And then in the others, I focused on specific topics. And today I would like to go into interactions. Here, the idea is that I would like to present you how to make information more accessible in your graph visualization. So the idea is that using interactions, the user actually can now change things in the graph visualization in order, for example, to get more details about the data or to exclude certain data or just to explore the data that you would like to visualize. So this is one idea. The other idea is that with interaction, you can also support the user in creating graph visualizations and modifying the graph visualizations for their purposes. And in the following, I will present this using the following structure. So I will divide the webinar into 4 sections, namely about the target elements, the tasks, principles, and actions. And for all of these, I will present then sub-aspects that you need to take into account when considering these main aspects. So for the target elements, I will talk about which kind of elements you can use for interactions, of course, not only in the graph visualization, but also in the background and decoration layer. Then I will also talk about tasks that you could solve using interaction. Here, the idea is that you typically want to answer a certain question using your graph visualization. And here, the idea is to define tasks that you could use to answer this question. And then I will talk about the principles, so about feedback, consistency, and discoverability using some examples. And then in the final part, I will talk about action. So this is a more technical part where it's really about what can you do or what kind of technical actions can you introduce in your graph visualization in order to implement the tasks that you have defined before. And I don't want to do this on a very theoretical level, but I would like to do this more on a level where I show a lot of examples, giving you ideas that you can also introduce in your graph visualizations. And as before in the other episodes of this series, I would like to use one example as a running example based on a music database, which is called Discogs. So this music database is a Wikipedia-like database that is based on many audio recordings, so more than 16 million entries about, for example, releases, and more than 8 million entries about artists and so on. So it's a really large database that has been maintained over the years. And the nice thing of this database is also you can query it using an API. And this is what we've done. And in the previous episodes, I've explained how to create a graph visualization that we can use to learn about the history of artists. So here the idea is that we represent artists as a path in a graph visualization, And this path goes through group nodes, and each group node actually represents a music group the artist was member or is member of. So for example, here, Paul McCartney is a member of the Beatles and also of the group Linda and Paul McCartney and so on. And the path illustrates the history of Paul McCartney with respect to his music life. And in the last episodes, I showed you how to create this graph visualization in a static way. So telling you how to design the layout, also tell you how to design the styling. And today I would like to show you how to introduce interactions. And first of all, I would like to show you this graph visualization. And to that end, I go to the playground. And you can also find this link in our chat. So if you also want to explore this example, you can also go to this playground. You find this playground also on our website. And here the idea is that you can basically use the entire Wi-Fi's HTML packet or library to play around with it and find out how to use it. And here, for example, I've used this in order to create this graph visualization on the history of artists. I just run the code to the left, and actually in this webinar I won't go too much into the details regarding the code. Just to briefly mention here, what you can see on the left-hand side is how this layout is configured. There will be an extra webinar about this for developers where I actually go into the details. Today, I would like to go to the right-hand side and have a look at the visualization. So as I've sketched before, the idea is that each artist is represented by a path that goes through these group nodes, and each group node represents a music group. And now we can follow this path here of Paul McCartney, for example, and see how the music life was of Paul McCartney. And as you already can see, when I interact with this visualization, I have a bit of a problem with this following these paths. And one interaction that I would like to show you later on is that you, for example, can easily highlight these paths so that it becomes easy to follow this path along these music groups. There are many other features in this visualization that I will show step by step during the webinar. Just to give you a bit broader overview of this visualization, the idea is that we have on the left-hand side the decades, and then the music groups are basically assigned to the different decades, and the paths go along the time axis from top to bottom, and this gives us a very easy overview of the different artists. So this will be the example that I will use as a running example, but I also will show you a lot of other demos to basically illustrate possible interaction techniques. So let's start with the first part, namely the target elements. So this is, of course, an important question. With which kind of elements can we interact as a user? And obviously, there are the graph elements, but besides these graph elements, there are also decoration elements and background elements. So what we can do is we can divide the visualization into layers and saying, okay, there is a background layer, a graph layer, and a decoration layer. In our use case, the background layer is just basically the table showing the decades. The graph layer is obvious, and then there could be also a decoration layer with legends. And of course, with each of these layers and with each of the elements of these layers, the user can interact. In this webinar today, I will mainly focus on the graph layer. And this will be a very brief section, just to mention the most important elements with which we can interact. Of course, there are the nodes, the edges, but also the labels of the edges and the labels of the nodes. Here also we have an external node label of the group node. With all of these elements, we can interact. Or put differently, any visual element that you can see here in this visualization could be also an element for interaction. And now I already want to go to the next section, namely talking about the tasks. So as I already said, typically you don't want to create the graph visualization for its own purpose, but typically would like to answer some certain question based on your data and using this graph visualization. So in the second episode, I described this, how to identify such questions, and now the question is, how can I answer this question using different interaction tasks? And I would like to show you few examples of such interaction tasks. Obviously, a very simple or basic interaction is navigation, where you can basically, for example, zoom and pan. So if we go back to the example, it just reloads shortly. And this is obviously not very surprising that we can do this in a digital drawing. We can zoom in and we can pen the visualization, and typically this already helps to navigate in your visualization. So in order to find certain elements in your visualization without changing this visualization. So basically the visualization is a static image, and you can zoom in and zoom out. And for example, using SVG techniques, you can be sure that it won't get blurred just by zooming in, but you get always a nice looking image. So this is obviously very basic interaction techniques, and most of the digital visualizations should somehow support these techniques. Another technique is that you use this not for, or with navigation, you could also mean that you not only want to navigate in your visualization, but you could use the visualization to allow the user to navigate in your data. And for example, also to go to external sources of your data. Here, this is a very simple example. If I click here, for example, on this node, or what you could imagine is that this graph here represents the structure of your website, and it shows just the users how your website is structured as some kind of table of contents. And the user could now use this visualization in order to navigate through your website. So if I click here on this, oh, no, that's, I'm sorry, that's, so if I click here, I get I get to Wired Live, which was the link behind this node. So basically, you can put such operations behind of the node. In our use case with the artists with the use case about the history of artists, you also can use this in order to link these, for example, these music groups to their to their information website. So if I click here on Pink Floyd, what happens is now that a new site is opened, namely the site of Discogs, linked to Pink Floyd. So this is also a very simple way to connect graph visualizations with external sources. So more complicated. So this typically means that you don't change your graph visualization, but you allow the user to somehow interact with this visualization by going to other sources or by changing the view on this visualization. But what you also can do is to use your graph visualization to explore your data in greater detail. So what do I mean by this? So for example, what you could do is you could set up an explorer that allows you to explore the relations between your nodes in your graph visualization. And here again, I would like to show a short example using our data explorer. So this data explorer you can also access on our website, and you can also play around with this. I just open here an example which basically first shows a schema or scheme of a database, which consists of customers, orders, products, categories, and suppliers. And this describes the database, but what it also allows here is to switch to another view where you can actually have a look at the data in this database with this certain structure. So here in this example, I just load some random example. And now this is a view on your data, but it's not the entire data set, but it's only a starting point of your data set. And what you now can do is using interactions is to explore this data and using this graph visualization. Here, for example, on this node, you see that there are 54 edges that are incoming and one edge outgoing. And if I double click on this node, the database is accessed, and we load these nodes live and then adapt the graph visualization showing the data. So here it's really about changing the graph visualization interactively, using it for exploration tasks on your database. And of course, I can go further, and then I see, okay, there are some cyclic connections in this graph. And this I can use to explore my data. What else I can do is I can show additional informations or I can explore additional informations on this graph visualization. So here the idea is that I don't change the graph visualization, but I just annotate it with further information on the decoration layer. So basically, I put further information on the decoration layer telling me some new information about the nodes. So this graph was about criminal cases. You can also find this on our homepage. And when I hover over this using this lens, what you can see is that we get some short informations about the nodes. And if I just drop the lens at one point, then I get further information. The idea is that at this point, it would be too much information to show all details at once. You could imagine that we put all these labels directly in the graph visualization, but this would clutter the graph visualization. Therefore, we just show the graph visualization and then annotate it with further information. Actually, you can also use this technique from before, where we just extended the graph visualization with further nodes and this lens together. So what we can do here is, for example, that we can click on this node here, and now the graph is extended. Okay, here I just extended it by one node. I can click here, so this graph is extended further. So here you see the combination of both techniques, where I extend the graph, but I also annotate the graph with further information. What you also can do with graph visualizations and interactions is to explore substructures. Here I would like to show you a demo that shows the Marvel cinematic universe. So the idea is of this graph visualization that you have different protagonists of this cinematic universe. So for example, Iron Man. And then when I hover over this, you also see that the path of the Iron Man is highlighted. This visualization is basically, or is really similar to the visualization about the history of artists. And what you can also do is you can click on these nodes, for example, here the Avengers, and what you get is a substructure or subgraph of the entire graph, showing you all Avengers movies. So it's just restricted to these Avenger movies, so that you don't get distracted by all the other movies. And this, of course, also helps you to explore your data lying behind this graph visualization. And finally, for exploration, I would also like to mention nested structures. Sometimes in your data, you have nested structures that you would like to visualize. And each structure could be, again, a graph visualization so that you can actually use graph visualizations in a nested way to visualize your data. So if I have a look at this demo, it's called Deep Zoom. What you can do is, for example, here you can zoom into one of the nodes and then go to the next node and to the next node and so on. And you can continue until, of course, you reach the bottom of your data, basically the bottommost structure. But this could be also a very nice interaction techniques for exploring your data. The next category that I would like to show is about searching in your data. Here again, you can use graph visualizations and interaction techniques. Of course, very simple searches like textual searches you could visualize. Here, if I go to this example, it's an organization chart about the company and its structure, and it's not that large, but already too large to find someone easily. So we have here some search field where you can just put in a name. Let's say, okay, I'm looking for Burns. And here you get the highlight directly in the graph visualization. So the highlighting is updated directly live. And when I press enter, what happens is that we zoom into the graph visualization and get further information about this person. So this is also quite simple technique, but also a very powerful technique, especially this that you then zoom into the graph visualization really tells the user where where the node can be found. This is also a typical technique that you can apply. Another way, or also very prominent example, are graph searches or graph queries. One of the most prominent examples is probably the shortest path problem. Here the idea is that you have a database and you would like to query the database. Let's say it's about flight routes on the world, and you would like to know how to get, for example, from LA to Frankfurt. And of course, you could just output some string and telling the people how the connection is. But here, a graph visualization really helps to give some idea how the route looks like, and using interaction, it becomes really intuitive to play around and find your own route through this network. And of course, here you can also think about much more complex networks and also about different types of graph queries in your data. Then I also would like to mention pattern detection. Here the idea is that you would like to find a certain or search for a certain patterns in your graph structure or in your database. In this example, I have considered fraud detection. The idea is that you have some entities in your data and they are connected, and you know that, for example, a cycle typically means that there's a fraud ring and you would like to detect this fraud. And of course, you can do this automatically, but sometimes it's more helpful also to have a human in the loop to detect such cycles and also to assess these cycles. And then what you can do is using interaction techniques to actually work with this visualization in order to change it and to find different patterns. So if I make this time window smaller, what you can see is that this cycle disappeared. but this here is still there, and I can change this over time. And so now assume that you would have only an static image of this graph visualization. This would be really difficult to play around or to work with this actually. And here, this is a quite simple way how to do this. So this is about searching, and of course, I also would like to mention that using graph visualizations, you can, of course, modify things and edit and create things. Most obviously, what you can do, for example, you could create your own graph visualization editor, as we have done using named Wired Live. I just want to show you it shortly. With this, you can create graph visualizations by your own by clicking it together. I just want mind map plan road trip was the suggestion. And I start with this. So what I've done here, I've just queried ChatGPT, and ChatGPT helped us to create this graph visualization. And now you can continue as a user to adapt this graph visualization and also to introduce new ideas into the graph visualization, connecting this. I think this is obvious that or it's a very basic use case for graph visualizations, and without interactions, this wouldn't be possible. And here you have these trivial interactions of creating edges, creating nodes, connecting nodes with each other, and so on. And also, of course, also styling them and changing the shape and all the typical possibilities that you also have in vector graphics. But this is not the only possibility or the only task that you could solve using interaction. But you can, of course, can also create other things using graph visualization. So here, in this example, on the left-hand side, you create a graph visualization in order to illustrate information. In the next example, I would like to show that you can actually use graph visualizations to change your data in the background. So again, this is basically an organization chart about people and then working, for example, in teams together. And there we have some relations. And this graph visualization could be just a view on your database, for example, or a data set that represents, for example, the structure of your company. And what you can do is that you can use these graph visualizations to change actually your data. So what you could do is that now the database is updated in the background and apply this. And of course, you can also create new nodes, and then the database is updated in the background as well. And using this interactive process, using graph visualizations, makes this much more intuitive than, for example, using just a textual input field. Here, for example, you could also say, okay, I connect those together and so on. This is also a possibility how to use graph visualizations for certain use cases. Even more complex is visual modeling. Here, the idea is that you use graph visualizations actually to model maybe an entire process, and then this entire model is translated into another product. So, for example, into source code that you then actually can execute. Here, as an example, I would like to show you our app generator that you can also use to to create your own applications in WI files. So the idea is basically that you use a graph visualization in order to create a program that again is able to create a graph visualization. So it's basically a meta model that you create here. So if you are familiar with WI files, you know that you can create your graph with a graph builder, and then you need to configure this graph builder. And this model here represents how to configure this graph builder. So I could introduce a further further label configuration. For example, I could just put it here and then I could connect this and then I could I could configure this further, for example, specifying some text binding and so on. And then what I can do is that I can use this graph model, which represents the configuration of the graph builder, and apply it on my specific data set. And then I get the actual graph visualization. And of course, I'm not interested only in this graph visualization, but I'm actually interested in the source code for creating this configuration. And here I can basically press the play button and then generate the source code. And this gives me then the possibility to create very easily an application for graph visualizations. And this is a typical example how to use graph visualizations. So as a kind of modeling language, you could also use it for different process that you would like to model. So for example, supply chains could be one example. Yeah, so this was about the tasks. Next, I would like to talk about principles. This is, of course, also important. So you have typically a lot of different possibilities to introduce interaction in your graph visualization. But you should not exaggerate on this and also know how to do this so that, for example, the user actually can discover these interactions. So I would like to talk first about discoverability. So this is really only a very short and broad overview of three important principles. There are many more, and there's, of course, an entire set of literature about this, so I can only sketch this. So with discoverability, you would like to improve the ease with which the user can intuitively navigate and explore the data. And this in the context of graph visualizations. So one possibility is that you, for example, introduce hints. So in Wired Life, we do this a lot. So there, if you create a node, what typically happens is that, or an edge, that you get some hints about how to interact with the graph visualization. So there are some controls that you can press and, for example, to create the node or to copy style. And of course, these are many different types of interactions and difficult to remember. So the idea is that you just show some hints about this, showing this to the user. Another way is to use contextual toolbars. Here I would like to show you this demo here. And the idea is that based on the element in your visualization, you get a different contextual toolbar. And especially in graph visualizations, this is a typical possibility because you have specified elements like the node, the edge, and so on. And for these, you can define such toolbars. Here, for example, if I click on this node, I can go to the next level and then I can change just the shape. For the edge, of course, I get another toolbar where I can specify, for example, the labels and so on. But I also can change the color. And this depends basically on the elements. But as we only have few categories of elements, it's a good way to show the user how to interact with your graph visualization. The next way to do this, to increase discoverability, especially in graph visualizations, is to use intuitive metaphors. You always should think about that graph visualization or graphs are an abstract structure which can become really complex, especially if you have complex relations between nodes. And sometimes it's then difficult to read these graph visualizations and also to interact with these graph visualizations. So one idea is to introduce or to use metaphors people are very familiar with. Here, for example, I would like to show a demo about maximum flow. So the idea is to find out the maximum load that a network can actually handle. So basically you have a source node and a target node, and you have some kind of flow that goes from the left to right. It does not need to be a fluid. It could be data, it could be some other kind of information, but you have some kind of load here. And you would like to find out what is the maximum load the network can handle. And here the intuitive metaphor is to say, okay, we model it as a fluid, because with fluids, we are all somehow familiar, and we know, okay, if I have a thin pipe represented by this edge here, then only, not only only less fluid can go through this pipe, while in larger pipes much more fluid can go through. And so typically when people use this demo here, the first thing is that they start to change the sizes of the pipes, and without thinking about this, because it's just intuitive to do this. And now I've changed the size of this pipe here, changing it maximum load to 40. And now what we recognize here is, okay, obviously there is some kind of bottleneck where we cannot put more load through. So what we need to do is we need to change this pipe here. And now we have increased the maximum flow in this network. This is basically a very intuitive metaphor to use. And when you have your graph visualization, it always pays off to think about such metaphors. Sometimes you can find them, and then it could be nice also to use them. Another example are Gantt charts. Here the idea is that everybody is somehow familiar with these tables where you can plan, so where you have from left to right the time, and then you have some categories, and then you would like to plan how long a certain process takes. And of course, you can connect these processes with each other, modeling dependencies. And here it's quite intuitive to say, okay, probably I can move these things around in this graph visualization, and I also can change the sizes of these of these nodes, because we just are used to this also in real life to handle these things like this. So also try to find such typical interactions from real life that you can transfer to your graph visualization. So this was about discoverability. Then about consistency. Here I would only go very fast through this. So of course, internal consistency means that we try to design our interactions such that once you have learned, you can refine them in your graph visualization. So for example, if you have a context menu for your nodes, with a certain structure, then the context menu for the edges should look alike. Of course, there are differences, but the main structure should be the same, and also the behavior, how you can change the graph visualization. But it's not only about internal consistency, but also about external consistency. So here the idea is to maintain the consistencies with external standards and conventions and expectations. So a very simple example is a right click typically opens a context menu. So you should not try to put things on a right click if in an editor, because people expect that a context menu opens. And of course, other things apply work in a very similar way, especially in if you think about a graph editor where you can change graph visualizations, then you should try to think about how is this done, for example, in vector graphics programs. So because people are used to this and know how to use this, and you should try to also use this in your visualizations. Next point is, of course, also about the feedback. So interactions can be used to change your graph visualizations, but you also should give feedback to the user in order to inform, guide the user, and just by confirming the actions of the user. So what do I mean with this? So one simple example is hovering. So if I hover over an item, I get some further information telling me, okay, you have just interacted with these elements, but you can also use more complex effects that I would like to show now. So for this, I again go to the wired live. I create a new diagram, and here I select one of these examples. Yeah, here a typical interaction response is that when I move this node, the group node changes its size as well. So this is quite easy and obvious, but it's also important to implement this because now the user can actually assess the new size of the group node and assess the change effect of the group node of the movement of the node. So assume that I would first move the node, and then after that the group node is adapted, then it would become really difficult to change the graph visualizations. So this is also a thing you may think of. And yeah, this was about the principles. Now I would like to go to the actions. So with actions, I mean actually interactions or technical ways how to integrate interactions into your graph visualizations. And again, I only want to show you a few examples, but important examples. So one thing is, how can you actually show more details in your graph visualization? So one thing that I've showed you before is, of course, the context menu. And this is not typical only for graph visualizations, but for any kind of visualization. But what you also can do is, of course, use tooltips in order to show further information. Again, this is not very typical for graph visualizations only, but for visualizations in general. So in this example, you have a graph visualization about board game recommendations, and you have here these little board games. And what you can do is you can interact with this graph visualization, but you can also hover over this element, and then you get further information about this game. And again, tooltips are a very simple and good way to reduce information the information density in your visualization, and only to show detailed information when it is necessary. Very similar to this is are detailed views. They are a bit more complex. So in this demo, I show you a computer network, and it also shows the traffic in this computer network. And what I can do is I can click on these detailed views, which are updated live, and they give you further information about single nodes. And they are really similar like tooltips. They are triggered a bit differently, but they can be used to show further information about your nodes, but also about edges or any other element in your graph visualization. And finally, for details, you can also use lenses, as I've shown you before with this demo about the lens that you can hover over your graph visualization. So I don't go again into this demo, but this would be also a typical example how to annotate your graph visualization with further details. You can also use animations to together with interaction in order to represent, for example, transitions. Here in this example, I've already showed you this fraud detection, where you basically can change the graph by changing this time window, and instead of just changing the graph by jumping from one static visualization to another, we show the change using animations, which helps to maintain the mental map of the visualization. Another example, also very nice for this, is transitions between layouts. So what you can do is Here I've changed the layout, so I placed the node somewhere else, and the layout is interactively or is incrementally updated, so that again the user can maintain the mental map about this visualization. This is also a very typical and important technique. And then what you also can do is you can animate the viewport. To that end, I would like to go back to the running example. Here, what you can do is that you can, for example, you can hover. Oh, this is, I think, the wrong one. Sorry, I think I have forgotten to update this link. So I just load the new. Yeah, this looks better. So there are different versions, and this one also contains interaction techniques. So if I hover over this, I get some information that probably I can interact with these elements. And when I click on this, I get now a viewport animation that goes along the path and then highlights every time the groups. So I can also use a bit longer path. I think Paul McCartney is one of these examples. Again, we just go along this path, and with this animation, or basically the interaction triggers this animation and gives me the feeling that I actually can work with this graph visualization. So as I said before, there will be also webinars where I explain how to do this from a technical side using by-files HTML. Yeah, the very same kind of viewport animations you can also use for different interactions. So for example, you have this really large or a wide graph, and you would like to go to one node, then I can click on this, or I could click on this edge, then I zoom to this. So basically, this helps me also to interact with the graph visualization. So this is basically a combination of navigation and animation. I also can use it for highlighting. I've already shown you this in the running example, but of course there are many different highlighting techniques, and you can really become very creative about highlighting. Here, for example, in this, we use some pulses to highlight certain structures. You can also use a shake effect. So there are many different things, and the idea is when you hover over the elements, the interaction again triggers some kind of animation that tells the user, okay, there is something you can work with, so you get some feedback about this. So editing, I already mentioned a lot of different things. So for example, you can change the geometry of the elements. This is also typically for vector graphics programs. You can change the styling. This should be also obvious. But you can also change the layout in graph visualizations, and you can support the user in changing these graph layouts. So in this example, what we can do here is that we can move around these nodes, and what you can see is that the edge routes are updated directly. And now when I do this, I get a crossing, but now then edge router is applied and the crossing is resolved. So the user is basically supported in creating a new layout. The user could also create a new class and place this, maybe place this class like this. And what now happens is again that the user is supported by rerouting the edges, but you could also offer the user the possibility to actually re-update the entire layout. This could be just by triggering it via a button, or it could be done automatically. And finally, about editing, I would also like to mention AI-based editing. We just have done some experiments on this with ChatGPT, and so you can also try it on your own in Wired Live. So I just load a new example, replace diagram. And here you can find a prompt field where you can prompt some things that you would like to change in this graph visualization. And the idea is that, of course, the graph editor often offers you a lot of possibilities to interact with this graph visualization. But of course, you cannot offer all possible interactions. So the idea is that you give the user the possibility to describe the interaction using a natural language. So I could say just, okay, select all nodes that have 3 neighbors. And I hope that it works now, because this works together with ChatGPT. And if you have worked together with ChatGPT once, you know that sometimes you get not the right answer. So we are still working on this. But if I press this, what now happens is that it selects all nodes with 3 neighbors. And now assume that you have a large graph and you need to do this by hand. Then this becomes really a painful procedure. But with this, you can easily change the graph visualization. So you could also say, make all nodes blue that have 3 neighbors. And actually what we do is we tell ChatGPT how or we query ChatGPT telling it that it should return us some source code that will solve this problem, and then we can basically execute this. And this gives us the very nice possibility to formulate very complex interactions which can be formulated easily in natural language, but would require complex user interfaces in graph editors. And finally, I would like to talk about focus views. Here, the idea is that we use, for example, filtering to reduce information. So the idea is that we take and focus on certain subset of the data. With filtering, I again have this demo here about fraud detection, where we just by making the time window smaller, we change the filter. So basically the predicate which kind of nodes and edges we would like to actually show of the graph. This is a typical filtering techniques, and also important in many of the graph visualizations you want to work with. So filtering, of course, can be implemented in different ways, but the idea is that you reduce the view by removing certain nodes and edges, and then you try to update the layout, normally in a way such that the mental map is preserved. Aggregation is similar. So, for example, here the idea is that the data is aggregated at the beginning, and then you can expand the data. This is also similar to the exploring examples that I showed at the beginning. And this gives you also the possibility to focus on certain aspects of your data. And finally, I would also like to show folding. Folding is used also to reduce the amount of data that is shown in your graph visualization. Here, for example, a group node contains further information, and it may also contain further group nodes and so on. And again, it expands the graph. But here, the difference to aggregation is that you have a nested grouping structure in your data that you would like to represent. So depending on your data, sometimes different interactions and different visualizations are necessary, and you need to decide on which to use. A bit more practical example for folding is again the running example about the artists. So if I go there, as you can see here, you have these group nodes, and what we can do is we can collapse these group nodes in order to reduce the amount of information. And of course, you can also not only do this group-wise, but for example, for an entire row. And the idea is again that you adapt the graph visualization smoothly so that you can still know where certain nodes are. Yeah, so much about coding. And so this already shows you different ways to use interactions in graph visualization. So you should have learned that there are many different ways of technical ways to introduce interactions in your graph visualizations, but it's always important to think about first about the task that you or the user should do or conduct in the graph visualization. And then when you have defined or identified these tasks, you can think about how to implement them in the graph visualizations, also taking certain principles into account. And with this, you can actually make the information in your data more accessible. And besides that, you can also make more information accessible. So information that you could have not found in the graph or in your data. But you can also use this interaction to support creation and modification. And with this, I would like to wrap up the main part of the webinar. So as I already said at the beginning, there will be, there were already some webinars about graph analysis and layout, also about graph styling, and today about interaction techniques. You can find the webinars also on YouTube, as well as the episodes before these 3 episodes. But there will be also episodes which will be more technical. So for each of these webinars, there will be also webinars about how to actually use Wi-Fi's HTML to achieve these aspects, considering the running example that I've shown also in this episode. Yeah, and with this, I would like to go to the question session. The idea is that I now will have a look at the chat, and then I will try to answer your question. So the first question is about so-called deep links. So the idea, when I understand this correctly, is that you use these links to trigger some certain processes, for example, in your application. So yeah, so basically, yeah, it's really like, okay, I click on a link in my visualization, and then it triggers some kind of process in my application. And the question is whether this is possible. Basically, the visualization gives you just a visual view or layer, which then can be used to trigger any process in the background. So this is more a technical thing that can be easily solved by just catching the click event, and then of course you need some kind of technical process in the background that triggers your actual process in your application. But yes, that's possible. So then there's one question about ChatGPT. It says that ChatGPT is not famous for logic. So is there something you do with a question and answer, or are you assuming ChatGPT will do it all right? So basically, yeah, what we are doing with this query is that we send it to ChatGPT, and we also send more or less some parts of the API of Wi-Fi's to ChatGPT and tell it to program against this API. And our experiences is that for many of these quite simple but still powerful requests that cannot be done or without complex user interfaces, ChatGPT still gives us code that actually works. So there are much more complex requests that we've already done using ChatGPT, which were correctly solved. But of course, there are also problems with this approach. It may happen that we just get a wrong answer, but then in this case, it does not matter, then nothing happens with the graph visualization and you need to reformulate. It's also more like currently an experiment we are doing. So the next questions, Are the algorithms poorly implemented by concept, or can you learn from existing visualizations? Yeah, so basically the question is all these layout algorithms and so how do we implement them? And what we've done is basically many of these our algorithms are based on well-known theoretical concepts and papers. We do a lot of reviewing of research in this field, but we of course also bring in our own ideas, our own experience. We have a lot of experience with graph visualization that is not always considered in research. And then we try to combine this, gaining our algorithm base. The next question is, does Y-Files also support touch key gestures as input? Yes, this is also possible. So you can use any type of touch gesture in order to also interact with the graph visualization. So basic gestures are implemented by default. So for zooming, panning, and creating edges, but the interface typically allows you really strong customization of the input mode. I think there are no further questions. No, it does not seem the case. Okay, I think with this I can wrap up the entire webinar. I thank you for the attention, and I wish you happy diagramming.